Hello and welcome to R&D Mathematics. Today we are going to talk about inequalities. So, for example, 3 less than 5. So, 3 is less than 5. Oh, 5 is greater than 3. So, it is the same thing. You can read it in either way. And if you had this, 3 is less than or equal to. So less than or equal to. Now, if we try to draw this in a number line, let's say 0, 1, 2, 3, 4, 5, and so on. Here, -1, -2, -3, and so on. So uh, x is actually greater than or equal to 3, or 3 is less than or equal to x. That means this point 3, let me circle it. Our x, it can be 4, it can be 5, it can be 4.7, it can be 6, it can be 1000, it can be anything to the right of 3, right? And we use an arrow to indicate that it can go forever. And also it can be 3 because of this equal part. So we shade that as well. So this is the graph of an inequality. And also, as you can see, unlike in an equation, that's the equal side, for example, let's say 3 equals x, that means just 3. That's your solution, only one particular solution. Or in a quadratic equation, you may have 2 solutions, but in an inequality, you have infinitely many solutions. And using interval notation, so this is the graphical notation, graph notation. If you want to write this in as an interval notation, 3 to infinity. Infinity is something that we cannot touch, so always using it with infinity, we use this open parenthesis. And with 3, because of this equal sign here, again, we use square brackets or square parentheses. Now, for example, if you had 3 less than x without equal sign, now in this case, somewhere here 3, everything to the right of 3, but not 3. So we do not shade that circle, and the interval notation looks like this. Open parentheses. So this is a good time to talk about a little bit about parentheses. So if you had A, B, this means everything in between A and B, but not those endpoints. If you had A, B, this means everything in between A and B, but this time we have A, not B. If you had A and B like this time everything in between A and B again, but with the right endpoint, not the left. And finally, if you had this time everything in between A and B, including both A, B. So these are 4 different kinds. Actually, these are finite intervals. It can be like, for example, A to infinity. That means everything starting from A to the right, because A is our leftmost endpoint and including A. Oh, it can be negative infinity to B, open parenthesis, let's say. So B is somewhere here, not including B, this is my right endpoint, and everything to the left. See, it can be like that. And let's do some problems. In order to solve an inequality, there are few tips. So tip number one, adding or subtracting. In simple words, you can add or subtract the same quantity on both sides. So we are here, solving inequalities. So solving. Let's see an example. Let's say 7x plus 28 greater than 29. So I would like to isolate the term involving x, that means 7x, so I need to get rid of 28. What I can do is subtract 28 from both sides. Yes, you can add or subtract, and inequality does not change, it remains the same. So here 7x. Now I'll stop there without solving it, because next one we can actually solve it. Multiplying or dividing by a positive number does not change the inequality. Now, for example, in this step we stop right here, so let's keep moving forward. So I would like to isolate my, I would like to solve for x. So what I need to do is divide by 7. Yes, you can do that because 7 is a positive number. Once you do it, you get x greater than or equal to 1/7. And if you want to put it in an interval notation, so let's say 1/7 is somewhere here, equal sign is there, you shade it, and everything to the right. Why? Because x is greater than 1/7. And if you want to put it in an interval notation, 1/7, that is the smallest value. X can be anything larger than that. So this final tip, multiplying or dividing by a negative number change. So it will switch the inequality. Now you must remember this. Now let's see an example first. So negative 3x greater than or equal to 18. Now I need to solve for x. So in order to do that, you cannot just, don't do that. Do not do that because it's a negative number. I suggest you writing down your inequality. Not writing down inequality, write down left and right sides, and you divide by -3, divide by -3. Because of a negative number, inequality changes because of -3. So you divide or multiply it, switch the other side. So -3 by -3, I get x is less than -6. So let's say -6 here. X can be anything to the left, and again we have equality sign in this one. So this, with an interval notation, it looks like this. Now, let's take a simple example in order to understand this about this. If I say x is greater than 1, it's very simple and you can understand. 1 is somewhere here, x is anything to the right, including 1. If I say negative x is greater than 1, now think carefully. Yes, with our previous rule, let me show you. Multiplying or dividing by a negative number change the inequality. So you can actually you can divide by -1 and you can get the solution. But without that technicality, just try to think about it. X is a variable. That's why we use the term x, and negative of that variable is always greater than 1. So let's say 1 is somewhere here. So negative x, so let me put it like that. Negative x lies here, right? For example, 5. 5 is a possibility for negative x. So what is x then? If my negative x is 5, x has to be over here -5, right? Because negative into -5, see, negative x, that's how it becomes positive, right? That's the reason. That's one easy way of explaining it. And if I use my earlier technique, what I need to do in order to solve for x, I write down -x and 1. So you divide by -1, divide by -1. Since you are dividing by a negative number, inequality changes. So x is less than or equal to -1. So our solution set in this case, somewhere here -1, x can be anything to the left of -1, which makes sense, right? Now think about this again. For example, if my x is -100, right? Negative x is negative into -100, which is 100, and which is greater than 1, which makes sense, right? That's the reason. That's the reason explained using a simple example. Now, with that knowledge, we can move forward. So 3x plus 1. Now let's try to find the solution and put it in interval and graphical solution. You know what? Again, pause the video and try this. First thing you have, okay, assuming that you have tried, first thing, distribute. Right, now take everything involved next to one side. So in order to do that, I have to subtract some quantity from both sides. Yes, I can do that. So I get 0, I get with these two x, so x plus 3. Now I have to subtract 3 from both sides. Yes, I can do that. Inequality does not change. X is greater than -3 in an interval notation. So x -3 somewhere here, x is larger than, so to the right, and sorry, graphical notation with interval notation, starting from -3 up to infinity, but not the left end point. So this is how you express that. And let's see another example. How about this? A little bit different one. 5x over 3 less than 4 plus 3x over 2. Now what? I don't like this 2 and 3. So, least common denominator of 2 and 3. Easily, that's 6. So I decide to multiply the whole thing by 6. 6 is a positive number, so inequality does not change. And I'm going to use parentheses in order to avoid mistakes. So 3 times 2, and that gives me 10x. 6 times 3 is 2 times 3. So now when I distribute, I get 12, 9x. Now I would like to subtract 9x from both sides in order to get rid of x terms in my right hand side. So I get this. And yes, that's the solution. So x is less than or equal to 12. So if my 12 is somewhere here, can be 12 because we have the equal sign, everything to the left now. Using an interval notation, so 12 is the largest number that x can be, so I put it in right. Anything to the left, so for example, negative 100 or negative 200, anything to the left can be in my solution set. How about this? Now these are known as double inequalities or double linear inequalities. Again, we are dealing with linear inequalities. We have something known as polynomial inequalities. That's a big thing. That's for a different video. Now, this is actually a combination of two different inequalities. What you can do, there are two techniques. So either you can treat, and see, I took this part and then I am going to take the other part. So you can treat them as two different inequalities and then you get some two different solution and then you can combine it. But since it appears as appear in a one piece, it's easy to just do it like, treating it as one piece. So let me use the second technique. That means, so first I would like to isolate my x term here. In order to do that, I have to add 2. So I am going to add 2 throughout this equation. All three parts I am going to add 2. So I get 5 here and 2 will cancel here and I get negative 5x, I get 15. Now I would like to divide by negative 5. Now I have three parts. Again, write down this, divide by negative 5, divide by negative 5, divide by negative 5. Because you are divided by negative 5, inequality changes. So inequality reverse because of negative 5. Now here negative 1, here x, here negative 3. So you have to be careful in an inequality like this. I'll address that in next example. Let's say, so first look at the numbers, negative 3 and negative 1. So it appears like negative 3 appears in this equation, negative 3 appears right hand side. But in reality, negative 3 is less than negative 1. So you have to be careful there. So negative 3, negative 1. And again, negative 3, x can be greater than, see this part, x is greater than negative 3. So to the right. And this part, x is less than negative 1. So to the left. So that means in between negative 3 and negative 1. And yes, including them as well. So in interval notation, this is negative 3 to negative 1. Now you have to be very careful here. Now let me address that over here. For example, let's say you ended up having a solution like this. Let me think. Okay, let's say for some inequality you had this. Now what? A common mistake. Again, in my videos I would like to address those common mistakes students make. Sometimes, sometimes we have to show the wrong thing in order to avoid it. So naturally students tend to do that. 1, 5. So you have to see the equal sign. You do this, you do this, and the interval 1 to 5, right? Think about this. If you pause my video and actually check it, most probably you may have got this, but this is wrong. You have to read this carefully. Okay. So what does this say? 1 and 5 years, they appear like this. And yes, you have equal sign. So now let's take this. X is greater than 5. So this side. And let's take the other part. X is less than 1. So this side. So now our solution set is union of two different parts. So negative infinity to 1, one part, 5 to infinity, the other part. And when we have pieces like this, using interval notation, using set theory, we use union. So this little guy known as union. And in set theory, we use unions and intersections, things like that. We'll talk about that in a second. Okay, I think that example is clear. Let's keep doing examples. This is what we need to do. Mathematics is something that you uh, practice, that you learn through practice. Just because you understand theory parts, you are not going to get good in math unless you practice it. Now, in this case, least common denominator of 2, 3, and 4, well, 12. So I decide to multiply everything by 12. 12 is a positive number, so nothing will change. I would like to, inequality does not change, and I would like to use parentheses just to avoid mistakes. Oh, and that's 3. So I get 9 here, I get 6 here, I get 4 plus 4y. Now I would like to subtract 4 from all parts in my double inequality. So I get 5, I get 4y, and I get 2. And now I would like to divide by 2. So 2 is a positive number. Inequality does not 2, sorry, by 4. 4 is a positive number. Inequality does not change. So I get y less than 5 over 4 and greater than 1/2. So this part, 1/2 is somewhere here, greater than it, including that. 5 over 4. Sorry about the interruption. So we were here. Y was 1/2. 5 over 4. So 1/2. 5 over 4, that's 1 and 1. 1 and 1/4, right? So that's obviously greater than 1/2. So 1/2. Y is larger than 1/2. 1 and 1/4 somewhere here. So 5 over 4. So in interval notation, this is our solution. Let's do another example, another quick one. So 3x plus 20. How about this? Now in this one, you have to multiply everything by 5. So I get 20. I get 3x plus 20 over here. See, I am avoiding some steps now. I would like to subtract 20. So I get 0 here. I get 3x here. I get negative 15 here. Only if you are confident enough to do those things in your mind. But I really suggest you working it out, and dividing by 3, inequality does not change. I get negative 5. Now again a common, okay, pause the video and try to draw it, try to put it in interval form. If you are asked to, even if you are only asked to put it in interval form, I really suggest you to draw it, because you see the reason. 0 and negative 5. Which one is the large number between these two? 0 and negative 5. And yes, we have equal sign in both cases. So this x is less than -5. So this side. X is greater than 0. So this side. Now this is one case that I was explaining earlier. So -infinity to -5 union, sorry here, 0 to infinity. Okay guys, that's all about inequalities. I think I did good number of examples. Next video we are going to talk about absolute value inequalities, but before that actually absolute value equations. So I have to introduce absolute value, things like this. So let's talk about that in our next video. Thank you.